In this lesson, we're going to start looking at solving word problems. So we'll take it bit by bit. The first thing we want to do is to decide which variables we're going to use to represent our unknown quantities. Sometimes we call these our let statements because we always start with let x represent. So for example, perhaps we are trying to determine how many dimes there are. So we don't have to always use x. I might use d. I might say, let d represent the number of dimes. In this question, we want to determine Katie's age, so I might use n for a number of years. This one, we have to represent the width, so I might say w is the width in centimeters. Now you'll notice that we are very specific in our let statements. We don't say things like let d be dimes. That is not specific enough. What is it about the dimes? Is it the color? Is it the size? Is it the shape? Is it how many? We don't say let n be Katie. Right? What is it about Katie that we're trying to determine? So you want to be specific when you're writing these let statements. So let's just have a look. So the variable that you're using must represent a quantity. That means it must be representing a number. You must have the units that you're measuring it in, and it must be specific. So let K represent Krista is not specific. What is it about Krista? Are we talking about her height, her weight, her age, her shoe size? So it needs to be specific. If you have more than one unknown, we will let one of the quantities be our variable, and then the other quantity will be written in terms of the same letter. So I'll explain that more as we look at some examples. Before we do some specific let statements, we want to look at the different ways we can describe our math operations. So when we are talking about adding, it might not say add, it might say things like the sum, the total, altogether, right? There's lots of different ways to say add. There's many different ways to say subtract. And we'll look at some specifically as we do some problems. So instead of subtract, we might say the difference. We might say take away. We might say greater than or less than or more than. That implies that there's a difference between two numbers. Some other ways to say multiply might be product or times. Of is also multiplication. Divide. Instead of divide, we might say quotient or each or per or average. Those are different ways to say divide. And then equals doesn't always say equals. It might say is or the same as or equivalent to. So there's lots of different ways to describe the operations, not just add, subtract, multiply, divide, or equals. Okay, so we're going to write two let statements for the following. So we have two numbers, and one number is twice the other number. So twice is an important word. So we're going to let's say n be the first number. Right, so I always let the first variable just be very basic. So n is going to be the first number. Remember that are two numbers. The second number is twice the first number or twice the other number. So twice would be multiplication. So the second number is going to be twice the first. So 2 times n is going to be the second number. So we're going to use the same letter. The first one will always be n or x, whatever you're using, and then the second one will be the same letter, but you're going to describe the relationship between the two. So in the second example, one number is 1/3 the other number. So I'm going to let n be the first number. And then the second number is 1/3. So I'm going to write 1/3 times the first number. Let's just tidy that up a little bit. Make it a little bit neater. Oops, that's not what I wanted. Okay. What are consecutive numbers? Consecutive numbers are two numbers that are one right after the other. So for example, 2 and 3 are consecutive. 10 and 11 are consecutive. So the next number, if the first number is n, the next consecutive number will be one more. So we would say n plus 1 will be the next consecutive number. If they are two consecutive even numbers, so an example of two consecutive even numbers might be 2 and 4. It might be 10 and 12. So we can see that they're increasing by 2 because they're even. So I'm going to let n be the first number. And then the next even number would be 2 more, so we're going to say n plus 2. Okay, if they're odd, so an example of two odd numbers might be 3 and 5. It might be 11 and 13. So even though they're odd, they're still 2 more, right? If I go from 3 to 5, I'm increasing it by 2. So let n be the first number. So the second number is still 2 more. So the fact that they're odd is not going to make a difference. The odd number will come out once you do the solution. But the difference between even is 2 and between odd is 2. Okay, so they're still increasing by 2. Now here we have a larger number and we have a smaller number. So I might say, so the larger number is described by the smaller number. So I'm going to let n be the smaller number. I don't want to use s because s kind of looks like a 5 sometimes, so I'm just going to use n. The larger number is 5 more than. So 5 more than n would be n plus 5, and that is the larger number. So n is, so I'm still using the same variable. N is the smaller number. The larger one would be 5 more, so it would be n plus 5. Okay, here we have the length of a rectangle is 6 more than the width. So the length is described in terms of the width. So I'm going to let w be the width. And then the length is 6 more than that. So the width plus 6 is going to be the length. Okay, this one's a little tricky. So the total number of blue and orange fish is 29. Okay, so it doesn't really matter which I use for the first. I'm going to let b be the number of blue fish. Now, the second part is tricky. I have 29 fish in this aquarium. If I remove the blue fish, the remaining fish would be orange. Okay, so we have 29 fish in total. If we take out only the blue fish, the orange fish would be left. So taking out the blue is subtraction. So I'm going to take the 29 fish, I'm going to take away the blue, and what would be left is the orange fish. So that one is a little tricky. You have to think about that one. The difference between two numbers is 5. So I'm going to let n be the first number. Difference means subtraction. So I'm going to let n minus 5 be the second number. Now, if you think about it, you could have n plus 5 if n was the smaller number and n plus 5 was the larger. In my description, n would be the bigger number, and then n minus 5 would be the smaller number. Okay, so it doesn't really matter which way you write it. Okay, the sum of two numbers is 44. So this is similar to the fish one. We've got two numbers that add to 44. Right, let's call them a plus b. So we have to describe in the same letter. So I'm going to let a be the first number. And I have to describe the second number in terms of a. So if we took out the a, so if we removed the first number from 44, we would be left with the second number. So 44 minus a be the second number, because that's what would be left over. Okay, Shannon's mark was 5 less than 4 times her French mark. Okay, this is another hard one. So Shannon's mark is described in terms of her French mark. I think this is supposed to say math mark. So I'm going to let F be her French mark. We have to use the same letter. So we have to think of order of operations. We have 5 less than. So less than means subtraction. And 4 times means multiplication. So we want to follow order of operations. We want to multiply before we subtract. So we're going to take the French mark and we're going to do 4 times that. So 4 times the French mark, and then we're going to follow that by subtraction. We're following order of operations. So 5 less would be minus 5. So her math mark is 4 times the French mark, and then 5 less. Okay, 3 consecutive numbers. So 3 consecutive numbers might be 2, 3, 4. So I'm going to let n be the first one. So between 2 and 3, we're adding 1. So the next consecutive number would be plus 1. And then the third one, well, we have to describe it in terms of the first one. So this one's going up by 1, but then if I go from 2 to 4, I'm going up by 2. So we're doing it relative to the first number. Oops. What did I just do there? I'll have to write that over again. That was weird. Okay, so we're going to let n be the first number. The next one would be 1 more. And then the third number in relation to n would be 2 more than n, right? So the next one, if n's the first, then we add 1 to get the next one, and then we add another 1. But if we're describing it in terms of n, then it would be 2 more. So that would be the third number. Okay, so these are just practicing writing your let statements. Once we get comfortable writing the let statements, then we're going to put the let statements together to make an equation. Then we can solve the equation and then answer the question that's being asked.